Hi and welcome to Probability Tree Diagrams. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So we begin with a bag that contains 3 blue blocks and 7 red blocks. Connor picks out a block at random, notes its colour, then replaces it in the bag. He then chooses again and notes the colour of the second block. Create a tree diagram to show the probabilities of all possible outcomes. Now, the reason that we're going to use a tree diagram here is because we're combining 2 different probabilities together, one after the other. And so what we look for is what the first situation is. And so in this case, it is just choice 1. And in choice 1, what could Connor select? Well, Connor could select either a blue block or a red block, and so at the end of the branches are the different choices that could be made. Now the branches need to have a probability assigned to them, and so this all comes from what was actually in the bag to begin with. So there were 3 blue blocks and 7 red blocks, so the probability that Connor would choose blue the first time would be 3 out of 10, because 3 blocks out of 10 were blue. The probability that he would choose red, well, that would be the rest. It would be 7 out of 10. Now, it is important, these 2 probabilities, the probabilities on the branches, should add up to 1. When we move on, what happens after he has selected the first block? Well, what happens is he takes a second choice. So we have choice 2. And when he takes his second choice, if he picked blue the first time, he may well pick blue again, or he may pick red. If he chose red the first time, he may well choose blue, or he may choose red again. The probabilities of each of those, well again, as he put the block back in, the probabilities have not changed. It is still a 3 out of 10 chance of picking blue, or a 7 out of 10 chance for red. A 3 out of 10 chance for blue, a 7 out of 10 chance for red. Now the question was, what is the to create a tree diagram to show the probabilities of all possible outcomes? Well, what that is actually saying is, what is the probability of getting blue followed by blue? The probability of getting blue followed by red. The probability of getting red followed by blue. And the probability of getting red followed by red. Well, the question is, how do we work that out? Well, the key comes from the fact that this is getting blue and blue. The word "and" in probability suggests that we should multiply. And that is what's going to happen. We're going to multiply across the branches. And so the probability of getting blue and then blue is 3/10 multiplied by 3/10. And if you multiply fractions, we multiply at the top and we multiply at the bottom. So 3 times 3 is 9 and 10 times 10 is 100. If I want to find the probability of getting blue then red, well, that would be the 3 out of 10 for getting blue and 7 out of 10 for getting red. 3 times 7 is 21 out of 100. The probability of getting red and then blue, well, that is 7 out of 10 times 3 out of 10, and so that is 21 out of 100. And finally, the probability of getting red and then red, well, that is 7 out of 10 times 7 out of 10, which equals 49 out of 100. And so those are the probabilities of each possible outcome. Now, just to check whether or not we've actually got this right, there is something we can do. The 4 probabilities we've just worked out were 9 out of 100, 21 out of 100, 21 out of 100, and 49 out of 100. What they should all do is add together to make 1. 9 plus 21 is 30, plus 21 is 51, plus 49. Well, there we go. If we add them all together, it creates 100 out of 100. They are all of the possibilities. They are correct because they've added up to 1. Now, as well, what we should notice here, these two probabilities have actually both ended up as exactly the same value. And the reason is that basically they're the same outcome. It's getting one of each, so getting a blue and a red. It didn't matter which order we did them, we still would have had the same probability. Now, if my question had been what is the probability of getting a blue and a red in any order, well then it would be one of these two. So either getting blue then red, or red then blue. The word or in probability suggests that we should add. And so we would add together those two probabilities and get 42 out of 100 in order to find the probability of getting one of each. So next we're told that Ben and Jerry play a game of tennis and a game of darts. The probability that Ben wins at tennis is 0.8. The probability that Jerry wins at darts is 0.6. Calculate the probability that they each win one game. Well, again, in our diagram here, we need to be thinking, how are we actually going to break this up? Well, the key here is that they play tennis and then they play darts. And so they are the two separate situations. Now, what are the possible outcomes? Well, the possible outcome for tennis is that Ben wins. And the possible possible outcome is that Jerry wins. For darts, exactly the same. Ben or Jerry. Ben or Jerry. And then the probabilities. So the probabilities are on the branches. It tells us that the probability that Ben wins at tennis is 0.8. So if the probability that Ben wins is 0.8, then the probability that Jerry wins must be the rest. And so that will be 0.2, as the probabilities must add up to 1. In darts, it says that the probability Jerry wins is 0.6. And so 0.6 for Jerry in both cases. Now, what does that mean the probability of Ben winning darts is? Well, it's 0.4 in order to make a total of 1. Now, if I wanted to find out the probability that each win one game, well, where on the diagram would that lie? Well, that would be Ben winning at tennis, but Jerry winning at darts, or Jerry winning at tennis and Ben winning at darts. And so, what are those probabilities? Well, the probability that Ben wins tennis and Jerry wins darts, well, that is 0.8 times 0.6. It is 0.48. What is the probability that Jerry wins tennis and Ben wins darts? Well, that would be 0.2 times 0.4. That is 0.08. Now this is the situation of the or, because it's one branch or the other. And so the answer to the question is then those two probabilities added together. So 0.48 plus 0.08. And so we get 0.56. Next, we have the situation where there are three possible outcomes as we work through. So in the situation, we have a bag which contains 3 red blocks, 5 orange blocks and 4 yellow blocks. I choose one block, replace it, and then choose another. What is the probability of choosing 2 blocks of the same colour? So once again, we have pick 1 and we have pick 2. They're just our two different situations. But then, for the first one, I could choose red, or orange, or yellow. And then, I could choose red, or orange, or yellow, red, orange, or yellow, red, orange, or yellow. And so the probabilities then just come from the bag as it started. So in the first situation, there were 3 red, 5 orange, and 4 yellow. So that is 12 blocks in total. So red was 3 out of 12. Orange was 5 out of 12 and yellow was 4 out of 12. Now because I replace the blocks, I put them back in the bag, that means that the probabilities don't change in the second pick. So again, it's 3/12, 5/12 and 4/12, and the same on the other branches. And the question was, what is the probability of choosing 2 blocks of the same colour? So where on the diagram would that be? Well, if I got red followed by red, that would be 2 blocks of the same colour. If I got orange followed by orange, it would be 2 blocks of the same colour. Yellow followed by yellow would be 2 blocks of the same colour. And therefore, I need to find each of those probabilities. So, if I got 2 reds, that would be 3/12 times 3/12. So I would have 9 out of 144. If I were dealing with getting 2 oranges, well, that would be 5/12 times 5/12, which is 25 out of 144. And if I was getting 2 yellows, well, that would be 4/12 times 4/12, which is 16 out of 144. But again, it is the first branch or the second or the third, and therefore I need to add those 3 probabilities together. So 9 out of 144 plus 25 out of 144 plus 16 out of 144. Well, if I add them, they're all going to be out of 144. 9 plus 25 is 34, plus 16 is 50. So 50 out of 144. Now technically we should also be thinking there, can we simplify? Well, we can. We can half both numbers. We'll have 25 out of 72. Next, we're going to deal with what is known as conditional probability. And so we are told that a bag contains 5 lemon sweets and 7 strawberry sweets. Sarah picks out a sweet at random and eats it. She then picks another and eats it. Create a tree diagram to show the probabilities of all possible choices. So in this case, once again, we do have your first pick and your second pick. But in this case, we could have chosen lemon or strawberry, and we could do that in both situations, in both picks. But when we come to the probabilities, in the first pick, it was 5 lemon or 7 strawberry. So 5 out of 12 for the lemon sweets and 7 out of 12 for the strawberry. Now the problem here is that after the first pick, Sarah eats the sweet that she's chosen. And so if she had happened to have picked a lemon sweet first, one of the lemon sweets has now been removed. And so there are no longer 5 lemon sweets. There are only 4. But also there are no longer 12 sweets in total. There are now only 11. But in terms of the strawberry, well, she chose a lemon sweet first, so there are still 7 strawberries, but it is out of 11 in total. At the bottom, this is suggesting that she chose strawberry first, and therefore there are still 5 lemon left, but we are down to 11 sweets. If she chose strawberry first and ate it, there is now 1 less. There are only 6 out of 11. Now again, if you have a look at the probabilities, these 2 probabilities add up to 1. These 2 probabilities add up to 1, and these 2 probabilities add up to 1. It is still the same situation, they must still add together to make 1. Now, it asks for a tree diagram to show all of the possible outcomes. And so, the first one is the probability of taking lemon and then lemon. And so that is going to be 5/12 multiplied by 4/11. And so we're going to get 20 over 132. In terms of the probability of getting a lemon followed by a strawberry, Well, that is going to be 5/12 times by 7/11. We're going to have 35 out of 132. Next, the probability of getting a strawberry followed by a lemon. Well, that is going to be 7/12 multiplied by 5/11. It's 35 out of 132. And the last one, the probability of getting a strawberry followed by a strawberry is going to be 7/12 times 6/11. We've got 42 over 132. Next, we're told a little bit of probability about rain. So the probability that it rains today is 0.7. If it rains today, the probability it will rain tomorrow is 0.8. If it does not rain today, the probability it will rain tomorrow is 0.5. Calculate the probability of it raining on at least one day. Well, in this case, how have we split our situation? Well, what we've got is day 1 and we've got day 2. What could happen on day 1? Well, it could rain, or it could not rain. Now, a little bit of notation that is often used in terms of probability is a little apostrophe. The little apostrophe means not. So the first one is rain, the next one is not rain. Now that could also happen on our second day. It could rain or not rain, rain or not rain. But then in terms of probabilities, we're told that the probability it rains today is 0.7. Therefore, the probability it does not rain is 0.3 in order to make it total to 1. On day 2, it all depends on what happened on the first day. So if it rains today, the probability it will rain tomorrow is 0.8. So that is the top branch. If it rains today, the probability it rains tomorrow is 0.8, meaning the probability it doesn't is 0.2. On the second day, if it does not rain today, the probability that it will rain tomorrow is 0.5, which means that if it doesn't rain today, the bottom branch, then the probability of it raining tomorrow is 0.5, which also means the probability it does not rain is also 0.5. Now, the question was calculate the probability of it raining on at least one day. Now, where on our branches would that be? Well, if it's going to rain on at least one day, well, that would be rain and not rain. There's one day that it rained. It rained on day 1. Or it rained on, or it didn't rain on the first day, but did on the second. But there is something else to be careful of here, and it's the word at least one. Now, if it rains on the first day, then it has rained on the at least one day, and therefore also raining on both days counts. And so what is the probability that it rained on both days? 0.7 times 0.8, so 0.56. The probability that it rained the first day but not the second will be 0.7 times 0.2, so 0.14. And the probability it didn't rain on the first day but did on the second will be 0.3 times 0.5, 0.15. And so the answer would be these three probabilities added together. So 6 plus 4 plus 5 is 15. 1 plus 5 is 6, 7, 8. So 0.85. Now, just to check that, we could actually see what was the probability of it not raining on at least one day. That would be the last probability, 0.3 times 0.5. Well, that is 0.15. Do those two probabilities add up to 1? Yes, they do. So one other way that we could do it is look for the probability that doesn't work and subtract it from 1. And so we end with the exam question. It came from the Edexcel paper in June 2018 and it was on higher paper 2. And it says a darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. If they win on Saturday, the probability that they will win on Sunday is 0.67. If they do not win on Saturday, the probability that they will win on Sunday is 0.35. Complete the probability tree diagram. So the first thing is we've only been given one of the pieces of information on the diagram, and that is the probability that they do win on Saturday. Now, if they do win on Saturday, it's 0.45. So the probability they lose must be the rest that makes that up to 1. And therefore, it will be 0.55. The rest of the probabilities are all conditional. They're all based on what has happened previously. So if they win, which means we are on the top branch, the probability they will win on Sunday is 0.67. So this value must be 0.67. Now from that, we can work out the probability that they do not win. Well, 0.67 taken away from 1, that would leave us with 0.33. If they do not win on a Saturday, the probability they will win on Sunday is 0.35, and therefore that is the win category here, leaving us with the rest for a not win. Well, that's going to be 0.65. Now it says, as our question, find the probability that the team will win exactly one of the two matches. So if they are going to win exactly one, where would that be? Well, it would mean they won the first game but lost the second, or they lost the first game and won the second in order to win exactly one. And therefore, the probability that they win and then don't win will be 0.45 times 0.33, and the probability that they do not win will be 0.55 and then win times 0.35, and so all we need to do is add together those two results. So we'll just pop that into a calculator, pop it in a bracket just to make sure. So 0.45 times 0.33 plus 0.55 times 0.35, and that gives us 341 over 1,000. Given that everything was already as a decimal, we'll go back to a decimal, 0.341. And that is the probability of winning exactly one of the two matches.